In this lesson, we're going to practice graphing exponential equations, and we're going to start by getting some values in an XY table, because when we can get some values in a table, we can plot them. Now, um, we remember probably from linear equations that we could put just 2 points on a graph, and then we could draw a straight line through it, right? Lines are straight, so if we have 2 points, then we know what direction it's going in. This is a little different because remember, we have an exponential here, which is going to result in a curve. So we don't know exactly what direction it's heading in. So really, we have to get a few more points so that we have its general shape. Once we have its general shape, you'll see how we're going to be able to connect this into a curve and get the graph on. So I just have an XY table here. We have the equation y equals 2 times 3 to the x. Now, you'll find that there's kind of a strategy you're going to be using over and over here. And it helps here to just to start with x equals 0 right in the middle. Why is that? It's because we know x is 0 starts right here. And we're going to want to get some negatives to see the shape over here. And we're going to get some positives to see the shape over here. And that's really going to help us out. So we're just going to start with 0 kind of right in the middle. 0 is also, you'll find the easiest one to kind of find, because why? When we say y equals 2 times 3 to the xth power, 2 times 3, well, if x is 0, we plug that in. What is 3 to the 0th? That is just 1. So we have 2 times 1, and it's 2. So we'll know here we're starting with 0, 2. Well, there's multiple ways to kind of go about this, right? We can understand what's happening in this equation, and you can also just kind of plug ones in. What if I go 1, 2, 3, and -1, -2, -3? I want to fill the rest of these out so that I can plot some and get kind of what the idea of the curve is. So, of course, you can just go and plug in x's. You can plug in x's and get out y's. That is always a strategy, no matter what equation you have. If it's got an x and a y, if it's got an input and an output, you can plug in the input and get the output. So we got 2 times 3 to the x is 1. That would mean 2 times 3 to the 1 is just 3, so 2 times 3 is 6. We can come over here and say 2 times 3. What about when x is 2? Well, 3 squared is 9, and 2 times 9 is 18. And finally, 2 times 3 to the third, when x is 3, 3 to the third is 27, and 27 times 2 is 54. Okay. You also could have noticed that what is the equation saying? The equation is basically telling us that there's a starting value of 2, start with 2, and then multiply by 3 some amount of times. So really, you can kind of think of this as what's happening, right? Multiplying by 3 once, multiplying by 3 twice, multiplying by 3 times. So really, you can start with 2 and multiply by 3 times 3 is 6. Multiply by 3 times 3 is 18. Multiply by 3 times 3 is 54. And there you go. Again, you can always plug in the x's and find what they are. So if we did something with these negative x's, right? If I say 2 times 3 to the -1, we just have to remember, what does a negative exponent do? Well, negative exponent, we'll flip it over. We're going to take the reciprocal, right? So we have 2 times 1/3 to the 1. Okay, to the 1 is just itself. 2 times 1/3 is 2/3. We got 2/3 here. What about -2? Okay, well, again, we're going to take the reciprocal. 1/3 squared is just 1/9. So 2 times 1/9 is 2/9. And again, what about to the negative 3? So 2 times 1/3 to the third is 2 times 1/27th, which is 2/27ths. Okay, again, we can think of this in a different way. If we're multiplying by 3 each time we go this way, this times 3, this times 3, this times 3, this times 3 as we go, well, we must be then dividing by 3 when we go the other way. So if you wanted to think about divide by 3, divide by 3, divide by 3, that's really what's happening. Multiplying by 3 as we go this way, dividing by 3 as we go this way. So, you can think about what's happening in the equation. You can also always just kind of plug in your x's and get out y's, whichever way you want to do it. And you might want to check yourself thinking about it the other way just to make sure it's right. But really, that's what's happening. We've got these points, and they are ready to be plotted. So we have 0, 2, 0, 2. We have 1, 6. We have 2, 18. And then we have 354. So 354 is way off. So we're just going to take the curve up as if it's heading to 54. Now this way we got 2/3. Now, of course, that is smaller than 1. So 2/3 of the way up to 1 is like here-ish. Then we got 2/9. And now don't kill yourself over what is happening, where is 2/9? It's a small number and it's close to this. So just kind of, put it around the area of 2/9. 2/27 especially, right? That is such a small number. Who cares where it is? It's really close. It's there-ish, right? So we're going to have a nice little curve that goes like this. It's going to go up and down here like this. So I'm going to start here and just do a little curve that goes up and heads off towards 54. And I put an arrow there. Now this one is going to go down like this and through these guys. And then where is this headed? Now, let's talk about where this is headed before I finish this graph, before I finish this curve, because weird things happen when we start moving this way, right? We're going to divide by 3. As we know, we're dividing by 3, dividing by 3, dividing by 3 as we go. So we have to consider, where are we heading if we're dividing by 3? What do we get to if we divide, let me throw this on the calculator here. If we divide 2/27 by 3, that gives us 2/81. Then if we divide that by 3, that gives us 2/243. We're getting very small here. If we divide that by 3, that is 2/729. Well, let's divide that by 3. That is 2,187. What's happening here? We're getting very, 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 very small. So we're dividing into 3 groups each time, divide into 3 groups each time. I like to think about halving is sometimes easier to think about. What if you had a piece of paper and you tore it in half? Say you wanted to divide it by 2 each time. You tear it in half. Okay, now let's divide that by 2, tear it in half. Okay, now take that piece, divide that by 2, tear it in half, tear it in half, tear it in half. You're going to get very, very, very small. Are you ever going to be 0? Am I ever going to run out of paper? Well, you're going to get very low to the molecular level if you can tear that small, right? Technically, we're not going to run out of it. We're going to theoretically go on for forever. And that's what really happens here. This is going to go towards 0, just get small, 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 but it's not going to hit 0. So we're going to leave that here. And what we do is draw a little dotted line right along here to say we're not going to hit 0. This is what we call a funny word, asymptote. Asymptote. Kind of a funny word, but that's what it is. Really, what that means is this curve is going to get smaller and smaller and smaller and smaller, but never hit zero. So this dotted line is saying y equals zero is an asymptote. We're going to approach this for forever and never hit zero. So quick little formal definition here. An asymptote is a value that a function approaches for forever, but never reaches. On a graph, we would denote it with a dotted line, so just like this. So this curve is heading towards this asymptote, and we're just saying with this dotted line that it's heading towards this value, but it's never going to reach it. Just like this. It's getting smaller and smaller and closer to zero, but it will never be nothing. So a little dotted line there. And that's how you would graph an exponential in this form. We're just going to create a table of values. We'll start here at zero. We'll go a few in this direction and a few in this direction. We'll get the general shape. We'll determine if there's an asymptote somewhere and put a dotted line where that exists. Send this curve off in this direction, and then send this curve towards the asymptote in the other direction. And there you